This video looks at the running fix method of fixing your position. The main difference between running fix and cross-bearing fix is the fact that we only have one fixed point to use to fix our position. Okay, the first example for a running fix that we're going to start with is slightly easier as it's got information already provided to us. So the question says, a vessel is at point P and has been travelling at 10 knots. The intended course is 0 degrees true. Okay. The bearing of a shore object O is taken at 9 o'clock. At 9:36, the bearing of the shore object is 270 degrees true. So what we're going to do is we're going to use the running fix method to fix the position at 9:36. So the first step is to plot the bearing of the object at the first time. So like I said, in this case, you've actually been given this information already, okay? If not, the bearing would be given to you and you would have to plot that, okay? So that's step one. Step one is yellow, okay? Step two is to plot the intended course. At this stage, remember it said the intended course is at 0 degrees true, which is straight up and down. Okay. Again, you may or may not be given this information. Step two is my green. Okay. Step three. At 9:36, the bearing of the shore object O is 270 degrees true. So let's mark that in. As always, the first thing I do when I'm marking a position is I draw a little compass. So what you should know with this one is we actually don't need our protractor because we know that this line here represents 270 degrees true. So all I'm going to do is I'm going to draw that line across until it intersects here with my intended course. Okay? So that there is step three. Okay. So the thing is, we can't guarantee, we don't actually know that from this point to this point is 10 knots, okay? The distance equivalent to travelling 10 knots. So we need to find what that actual distance is for our next step, okay? So we go back to what we know with our speed, distance, time. Okay, go back to our trusty old triangle. Distance, speed, time. Okay, this time we need the distance. So distance equals speed times time. Distance equals, we're travelling at 10 knots, which is 10 nautical miles per hour. So we were travelling from 9 till 9:36. So we were travelling for 36 minutes. But because this is in nautical miles per hour, this must be given in hours also, okay? So my distance equals, put that in your calculator, I did this earlier, 6 nautical miles, okay? So in that time, that's how far we've travelled. We need to mark that on our line. So let's come back. So I'm going to use my scale. This time I'm working backwards from the scale, a little bit different to when we do our cross bearing. So this time I said I've gone 6 nautical miles, which remember is the same as 6 minutes. 1, 2, 3, 4, 5, 6 minutes, which is on my ruler about 7.7 centimetres. Okay, so I'm going to take my ruler. I'm going to measure that 7.7. In this case, it's actually very close to where we had marked. Okay. In this case, it's very close to our line. Alrighty. So the final step, what we need to do. So remember, my boat can see this object on a bearing of 270, which means the boat is somewhere along this line. So what I need to do is I need to take my ruler to make sure it's still on this bearing, move it up as accurately as I can, and find the point where this point intersects with my pink line. Okay, there we go. So now at this point here is where my boat is at 9:36. Okay, so that there is step, well, technically that's step 5, because step 4 is calculating the distance. Step 4 equals, so I'll move this up, calculate distance. Okay, so just to recap, a vessel is at point P and has been travelling at 10 knots. The intended course is 0 degrees true. That's that green line. The bearing of the shore object O is taken at 9 AM, which is this yellow line here. You will not always be given these lines already drawn. You may need to draw them yourself. Okay. At 9:36, the bearing of shore object O is 270 degrees true, which is this one here. Use the running fix method to fix the position. So after we've done step 1, 2, and 3, we calculated the distance by using our distance equals speed multiplied by time. Step 5, we marked it on, then used our ruler to measure up and find out where the line intersects. And that's how you do a running fix.